Let's move on with our special products from 5 to 8, shall we? So for 5 to 8, here we go. So again, for all A, B, C in the real numbers, what we have is, so we have, for number 5, quantity x plus a times quantity of x plus b. What happened here? So notice the first terms are the same, but the second terms are unfortunately not. So if that's the case, what we will do is to square the first term rather, add the the second terms rather, the two second terms, add them together, put an x as a factor, and then for the last term, multiply the two terms together, which are not the same. So for example, let's put it here. Say we have, let's have another number. Let's make use of, say, v. V plus, let's make it simple again. Let's make it 3. V plus 3, and then shall we have v, because the first terms must be the same, v minus, say, 2. So if this is the case, what we will do is we're going to square the first term. This is equal to, so v squared, right? And then add the two terms, the two last terms. So we're going to add them. 3 plus minus 2, that's going to give us 1. So that's positive, so positive 1. We don't need to write that one. And then put the first term, that's v, so v squared plus v. And then plus ab, plus ab. Ab is multiplication again. We're going to multiply the first and the second term. So 3 times minus 2 is minus 6. So since it's negative, let me delete this. Okay, and this is our answer for number 5. This is one example for number 5 rather. For number 6, so we have ax plus b times cx plus d. What is happening here? So we have a common variable, the x's in the first terms, but their coefficients are not the same. What happened here in number 5 is that the coefficients are the same. They are strictly 1. Here, we have a coefficient which is a, which is in the real numbers, c, which is also in the real numbers. And what will happen here is that we're going to multiply first a and c, the coefficients of the first two terms, square the x, the variable, square the variable. And then we multiply a times d, the last terms, plus the product of the inner terms. And then we multiply the two last terms, bd, which is b here and d here. Okay. Now we'll follow that, and then I'm going to give you one example. Say we have, let's be contented with small numbers here. Say 2. Let's make use of another variable, say 2y plus, that's constant, 2y plus, say 1 times 4y minus 5. Okay, so what will happen here? We're going to follow the process. AC, so 2 times 4 is 8. X squared, which is the first term, b squared. So we have y. That's going to become y squared. Okay, plus AD. What's AD? The last terms. 2 times minus 5 is minus 10. And then plus BC. BC is the inner term, so 1 times 4 is positive 4. And then copy the variable y. And then we just simply multiply the last terms. 1 times negative 5 is negative 5. Okay, it fits. Okay, and then I think we need to simplify the middle term. So what we have is 8y squared. Negative 10 plus 4 is negative 6. So let's make that minus 6y minus 5. And then that's our example for number 6. Okay, for number 7, I'm going to put it here. So a plus b times quantity of c plus d. So for all a and abc in the reals, so let's make it very simple one. So we'll have plus 2 x plus 2 times the quantity of y minus 7. Okay, so what happens here is that we're going to multiply first the first terms added by the product of the last terms, the outer terms, added by the product of the inner terms, added by the product of the last terms. Okay, so actually this number 7 is what we call our FOIL method. So this is the FOIL method. The FOIL method means um, first, outer, inner, and last. So we're going to add the product of those numbers. So if we're going to follow the FOIL method, this is actually the standard way of multiplying binomials. Okay, so first terms x times y is xy. Outer terms x times minus 7 is minus 7x. Inner terms 2 times y is 2y. And last terms 2 times minus 7 is minus 14. And that's our answer for number 7. For number 8, may I put it here? I'll try to fit. So we have a minus b quantity cubed. So if we're going to have that, actually I have a separate video here for number theory. We can use the binomial theorem, the expansion of this, but let's be contented by this formula anyways. So say for example, we have that a be 1 minus y cubed. Okay, so what will happen here is that the first term is going to get cubed minus 3a squared b plus 3ab squared minus b cubed. Imagine the a as the first, b as the second term. So we have here as our a 1, we have y or minus y as our b. So what will happen here is first, for the first term, a cubed. So 1 cubed is still 1, right? 1 cubed is still 1. Then minus 3 a squared, 1 squared is still 1, and then b, so b is minus y, so I think I'm going to put here y, and then this becomes positive since y is negative. Okay, and then for the third term we have 3 plus 3, a is 1, and then negative y is going to become negative y quantity squared, so that's going to become just 3y. Okay, and then 3y squared rather, since y is being squared, and then minus b cubed minus y minus negative y, so this becomes like minus negative y being cubed. So negative y being cubed is simply negative y, so negative times negative, maybe we can get rid of the negative sign, so this becomes positive y cubed. And that's our answer for the number 8. Okay, and that will be our part for the second, I mean our second part for our videos and special products.